Yeah, hello guys, welcome to the video. Today in this video we are going to study about charge and Coulomb's law. We will study everything about Coulomb's law even in vector form so that you will be able to solve questions up to JEE advanced level. Uh, Please subscribe to my YouTube channel before I start. I should request you one more thing. In this YouTube channel, I will teach you mathematics for JEE Main and Advanced, and also the physics for NEET, JEE Main, and JEE Advanced. Okay, I hope you will enjoy this video. First of all, now I am going to start with charge. I am going to start with charge. What is a charge? It is the intrinsic property of a matter. I hope you are aware about this thing, intrinsic property. If not, I will tell you briefly in this lecture. It is the intrinsic property of a matter. What are the intrinsic properties? It is just like the inbuilt things in your phone. When you buy a phone, you get something which is inbuilt in it. Already there, it is present inside the phone, like 4 GB RAM, 8 GB RAM, whatever. The software to run your mobile phone camera and all. These things are intrinsic. Same way. Whenever there is a matter in the whole universe, it will have some properties like mass, charge, etc. These are the intrinsic properties. Okay, now come to the point that where the charge lies inside the matter. The charge is contained by some tiny particles called charge carriers inside the matter. Okay, some tiny particles, and I hope you all know, since you are studying for standard 12 physics, you all know what are those tiny particles from your standard 11 chemistry concept. Those tiny particles or charge carriers are electrons and protons in the atom, the electrons and the protons. Okay, now the thing which is to be noticed is, does any atom has fractional number of electron or proton? The answer is no. Any atom cannot have 2.5 protons, or let's say 10.5 electrons, or any number like this. Any atom cannot have simply the fractional number of electrons or protons or charge carriers. Okay, so that's why any matter cannot have the fractional quantity or fractional multiple of charge. Okay, fractional multiple of a minimum value of charge. That minimum value is called the quantum of charge. Now, quantum of charge, what is it? What is the quantum of charge? Quantum of charge is the minimum charge that a particle can have. Now, if it is having minimum charge, it means it will be having only one electron or only one proton. So what is the charge on one electron? It is minus 1.6 into 10 to the power minus 19 Coulomb. Coulomb is the SI unit of charge. And what is the charge on proton? It is plus 1.6 into 10 to the power minus 19 Coulomb, right? So here E is the quantum of charge. E is the quantum of charge. Okay, and next point in this is, if any matter, or let's say any atom, cannot have the fractional number of electrons or protons, so it cannot have the fractional multiple of this quantum of charge, right? So from here we come to the law of quantization of charge. Law of quantization of charge. It says that charge on any atom or in any matter, in our case, will always be the integral multiple of the quantum of charge. The quantum of charge. This is quite clear actually from common sense, that the charge cannot be fractional multiple of protons. The charge on any matter cannot be the fractional multiple of electrons also. So what do we write if there is q charge on any atom or matter? What will it be? It will be plus minus m into E, right? Where E we have already discussed, and n is an integer. Okay, this is law of quantization of charge. Okay, now there are some methods of charging like rubbing, conduction, induction. You can find it in any standard book. If you will just give it a reading, you will be able to understand. So I am not going to those parts. Now I am directly jumping to Coulomb's law. Now I'll talk about Coulomb's law. What did he told us? What did Coulomb told us? He gave us information. He gave us information about electrostatic force acting between 2 point charges. Now let us say there are 2 point charges q1 and q2, which are separated by a distance r. Then in that case, the force, the electrostatic force, will have magnitude and direction, because it is a vector quantity. That's why, right? So what will be the magnitude? First of all, we will talk about the magnitude. Coulomb told us that the magnitude of this force will be proportional to the product of charges, and it will be inversely proportional to the square of separation between them. If we are going to combine them, we will have to write F is proportional to Q1 Q2 by R square. Now to bring an equality sign, we will have to multiply it with a proportionality constant. This K is proportionality constant. Proportionality constant, and it has a value. It is actually more specifically equal to 1 by 4 pi epsilon naught. I'll talk about epsilon naught. And its value is 8.995 into 10 to the power 9 Newton meter square per coulomb square. Okay, now for ease of calculations, we write K is equals to 9 into 10 to the power 9, simply Newton meter square per coulomb square. Now what about this epsilon naught? K was equal to 1 by 4 pi epsilon naught. Here this is actually EPSELON, epsilon. It is a Greek alphabet. It is a Greek alphabet. This is called the permittivity of free space. Here the thing which should be noted, the point to be noted over here is that the system, this two charge system is kept in vacuum, okay? There is no medium present between them, okay? So here it up, it is present in vacuum. There is no medium present between them. That's why we are using the epsilon naught over here, which is actually permittivity of free space. As soon as the system will be kept inside any medium, what do we have to write over here? We will have to write the permittivity of that medium over here. I will talk about this thing in my next lecture. Okay, for today, just know this much. Now, what is the value of epsilon naught? What is the value of epsilon naught? It is 1 by 4 pi into 9 into 10 to the power 9, right? When you will calculate, it will come out to be 8.85. into 10 to the power minus 12, and the unit will be Newton inverse meter power minus 2 Coulomb square. Okay, I hope till here this is clear to all of you. So finally, what can we write for the magnitude of the electrostatic force between any two point charge? It is 1 by 4 pi epsilon naught q1 q2 by r square. It is this much. Okay, now what about direction? The thing which should be noted over here is the electrostatic force, between 2 point charges always act along the line joining them, Now, if the charges are opposite, then force is attractive. And if the charges are like, means both the charges are having same sign, in that case force is repulsive. Okay, so if both the charges are positive or if both the charges are negative, then in that case the force will be repulsive and it will act along the line joining them. And if both the charges are having opposite signs, then in that case the force between them will be attractive and it will act along the line joining them again. Okay, now next thing, Coulomb's law in vector form. What if we have been given the coordinates of charges, or let's say not the coordinates, the position vector of charges, and we need to find the force. As we know, force is a vector quantity, so we can write it in the vector form. Let us say this r1 is the position vector of q1, and this, let me draw it clearly, this r2 is the position vector of q2. Then this r vector has some significance. What significance? Let us see. F, when we write 1 by 4 pi epsilon naught q1 q2 by r square, then this r is the magnitude of this r vector, right? Because it was the separation between q1 and q2. I hope you are understanding this. Now have a look from triangle law of vector addition. From triangle law of vector addition, what do we have? We have vector r1 plus vector r is equals to vector r2. It means we have vector r is equals to r2 minus r1, right? And the next point to be noted over here is the force, the electrostatic force will act along this line, because q2 is over here and q1 is over here on this line. The force was acting along the line joining q1 and q2. Now if both the charges are of same nature, let's say both are having same sign like positive or negative, then in that case the force will act along this direction, right? Have a look on the direction of vector r. Vector r is like this and the force is like this. Aren't they pointing towards the same direction? So if we want to write this force in vector form, can we write it like this? The answer is yes. Okay, we can write it like this. Now have a look. We are going to do some algebra, vector algebra over here. What do we have? R square. Can we replace it R square as magnitude of R2 minus R1 square? And this R cap, can't it be written as R1 minus R2 upon magnitude of R2 minus R1? So finally, what do we have for the force? We have 1 by 4 pi epsilon naught Q1 Q2 by R2 minus R1 magnitude whole cube into R2 minus R1. That's it, guys. This is the Coulomb's law in vector form. I hope this is clear to all of you. Now, over here in this expression, you can see vector R1 and R2 was given to you, Q1 and Q2 were given to you. Just put the values, you will get the force. One thing that should be taken care of over here is you will have to put the values of Q1 and Q2 with sign. Check, check, check. Check it, guys. Okay, you will have to put these values with the sign. Okay, I hope till here everything is clear to you. You can attempt now the questions of Coulomb's law from any standard book. And thank you for watching the video. In the next video, I'll come up with the permittivity things, electric field, and electric potential. Please like, subscribe, and share the video. Share it with your friends who are preparing for JEE and NEET. And I also teach on Unacademy. Please visit the Unacademy app or website. Go to the IIT JEE goal and search for my name and follow me for the free live classes over there. Thank you, guys. Thank you.